let's actually look here. Find one positive and one negative coterminal angle to 60 degrees. Well, this is not too difficult if you know that you have to go around 360 degrees. Doesn't matter which direction, and you're going to want to land in the exact same spot. So we want to land at 60, but let's do an additional 360 degrees. So you can go 360 plus 60, 420 degrees. So 420 degrees would land you in the exact same spot. You just went an extra 360 degrees. Now let's do two 360s, or 720. So then 60 and 720 degrees would be 780 degrees. That would be another coterminal angle, landing in the exact same spot. However, they also want us, I found two, but both of them are a positive number, and they want a negative coterminal. Okay, well that's not too difficult. We can just subtract 360, like I did in that previous one. 360 or 60 take away 360. So that would be, if you don't know how to do that, you can just go 360 subtract 60. So change the signs. 0 minus 0 is 0. 6 minus 6 is 0. 3 minus nothing is 3. It's positive 300, but because I switched the signs, I will make sure I switch the sign here and do a negative 300. So that is also a coterminal angle. I just subtracted 360. Or if you wanted to, you could subtract 720 degrees. So 720, take away 60. Again, I'm using the wrong symbols here, but I'll flip it after. 0 minus 0 is 0. 2 minus 6, I can't 2, so I'll borrow from there. Make that a 12. 12 minus 6 is 6. Carry down the 6. So 660, but I need to change the sign, so I'll make it negative. So you can add as many 360s as you want, or as many 720. You get a 360, you get a 720, and another one would be maybe a 1080. And you can keep going. I've done more than what they've asked here. I've done two positives and two negatives, but they're all would land in the exact same spot. So they're all coterminal 260. Now another thing that we need to do is reference angles. Definition: consider the angle standard position. The reference angle of theta is, well, what is it? So let's first do an IE, a little drawing, and let's label this halfway right there, 135. The reference angle is the angle that's between the terminal arm, so I'll do that in green, the terminal arm, and the horizontal, the x-axis. So I've got two options. I've got that gap and that gap. And you just have to remember that it's always going to be something that's less than 90. So it looks to me like this thing is way larger than 90 degrees. I mean this part right here is 90, and then you have the additional part right there. So this, we're only going to be looking at a reference angle. The only thing that we're looking at is right there. So between the terminal arm and the x-axis, assuming it's less than 90 degrees. And so this gap, this is 180, this is 135. The difference between them is 45 degrees. Okay, i.e., if you had this, and I'm calling this 210 degrees, it's the gap between the terminal arm here and then the horizontal. And then you have to ask yourself, well, is it that one or is it this one? And it's the one that's less than 90, so it can't be that big gap. It's that one. And what is that? And you just have to do some simple math. Is label this as your 180. 180, what's the gap between 180 and 210? Well, the gap there is 30 degrees. So you would say, for both of these, theta, the angle that you're looking for, theta r, the reference angle, is 45, and the reference angle is 30 degrees. Okay, so consider the angle in standard position. The reference angle of theta is the angle between the terminal arm arm and the x-axis. And the x-axis, note, has to be less than 90 degrees. So 89.99999, that's your max. The maximum it can be is 89.999. Can't even be 90. So that is what a reference angle is. So if you're given an angle, so I was given an angle of 135, my reference angle was 45. My angle that I was given was 210 degrees. My reference angle would be 30. So, oh, I should also indicate here, it's less than 90 and it's always positive. So keep that in mind. It can't be a negative. A reference angle is always positive. So how do you find reference angles? Well, usually you have to just draw them. So I've got 150 degrees. How do you draw that? Well, I label 180 and then this is 90 and 150 is somewhere in there. 135 would be right halfway in the middle, and so I have to do a little bit less than that. So 150. So what is the reference angle? Well, it's that little gap right there. So theta r is the difference between 180 and 150, which is 30 degrees. Moving on, 320 degrees. Well, I know that this one down here is labeled as 270, and this one is labeled as 360, and halfway in between is 45, so 270 plus 45. 0 plus 5 is 5. 7 plus 4 is 11. 315. So halfway in between is 315, and I'm doing 320, so it's a little bit more than that. So I've labeled this, whoops, a little bit more than half. Label that as 320. And I want to find the reference angle. So it's the terminal arm, and the x-axis is that little gap. And that gap right here looks like it is 40 degrees. All right, so next one. Negative 225 degrees. Okay, so this is 0. We know we're in the negative direction, so negative 90, negative 180, negative 270. Okay, nice. So it's somewhere over here. I want to know the halfway point. Okay, so what's the halfway point? So you go halfway to 45. So 180 and 45, if you add them, 0 plus 5 is 5, 8 plus 4 is 12, plus that 225. So halfway is 225, and I need 225. Okay, so I'm going to go right here, negative 225. That's what I have. That's the angle that I'm given. I'm going to erase all these other angles. So the reference angle is the gap in between. So theta r is the gap between here and here. Well, that's exactly 45 degrees. It's not negative. We keep it positive. It's always positive. So our theta was negative 225. Our reference angle was 45. Over here, our theta was 320. Our reference to that was 40. The last one is 30 degrees. So halfway in between is 45, and I want to go less than that, so I want to go 30. So I'm at 30 degrees. The reference angle is right there, and this is 0. Sorry, this is 0, 90, blah, blah, blah. So the gap between 0 and 30 is 30. So my reference angle is 30 degrees. So this is a strange one because the reference angle matched the angle that I'm given. And that's always going to be true if you want to leave a note. The reference angle and the original angle they gave us, so the stated angle, are the same in quadrant 1. And this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And so in quadrant 1, they stated the angle was 30, the gap in between is 30. But I could state anything. I could state right here, that angle, this is 90, I'm going to call this 80 degrees. So if I stated an angle of 80, what's the reference angle? Well, the reference angle would be here, theta r. Well, but the gap between 0 and 80 is still 80. So my reference angle matched my stated angle, and that's only true in quadrant 1. You don't need to know that. The rule still applies. There's the terminal arm and the gap in between, but if you wanted just a quick way, quadrant 1, they always are going to match. Again, we're going to use all this information and as well as last day's information, and we're going to put them all together to solve some more questions.